Welcome back, mathematicians. In this video, we will be working through converting rectangular coordinates to polar coordinates. Real quick, it's important to remember that every ordered pair in rectangular coordinates does correspond to an ordered pair or point in polar coordinates. As a result, if P is a point with rectangular coordinates x, y, the polar coordinates r, theta of the point P are given by, if x is not equal to 0, r squared is equal to x squared plus y squared. Tangent of angle theta is equal to y over x. However, if x does equal 0, that means that tangent of theta is undefined. As a result, if x is equal to 0, then we know theta is equal to pi over 2 and r is equal to y. Let's now use this information to find the polar coordinates of the ordered pair 3, -3. Let's start by finding the value of r. We know r squared is equal to x squared plus y squared. Replacing the values for x and y, I get 3 squared plus -3 quantity squared. Simplifying this, I get a value of 18. I need to find r, however, so I'm going to take the square root of both sides and simplify the radical to get r is equal to 3 times the square root of 2. I now need to find theta, and I could use tangent of theta is equal to y over x. However, I'm more of a visual person, so I'm going to draw a coordinate plane, rectangular coordinate plane, and I'm going to plot 3, -3. So that would be 3 units to the right and 3 units down in quadrant number 4. I'm then going to go ahead and draw the initial side of my angle and then the terminal side, which should go through that point 3, -3. What I'm looking for is this angle theta that has counterclockwise rotation from the initial side to the terminal side. What I know is that I can form a right triangle, and so the horizontal distance on the right triangle will be 3, vertical distance is -3, and I know the radius is 3 times the square root of 2. What I have here is a 45, 45, 90-degree triangle, which means that the reference angle is equal to pi over 4. As a result, angle theta is equal to 2 pi minus pi over 4, which would be equal to 7 pi over 4. So my final answer, 3, -3 in rectangular coordinates, can be rewritten or is equal to 3 times the square root of 2, 7 pi over 4 in polar coordinates. Let's now try to find the polar coordinates of -2, 2 times the square root of 3. So again, I'm going to start with the value of r. So I know r squared is equal to -2 quantity squared plus 2 times the square root of 3 quantity squared. This gives me a value of 4 plus 4 times 3, which is equal to 16. That means r is equal to value of 4. I now need to find the angle theta, and once again, I could use tangent of theta is equal to y over x. However, I'm a visual person, so I'm going to go ahead and draw myself a quick picture, and I'm going to plot -2, 2 times the square root of 3. So I'm going to go 2 units to the left. Now 2 times the square root of 3 is approximately 3.5, so I'm going to go up 1, 2, 3, 4 units. So my point is approximately here. So it's 2 units to the left and about 3.5 units up. If I were to draw my angle, I have my vertex on the origin, I've got my initial side, and my terminal side should go through that point. I'm now going to go ahead and draw a right triangle, and I know the horizontal distance is going to be -2, vertical distance is 2 times the square root of 3, and I know that the hypotenuse or radius is a value of 4. What I have now is my 30, 60, 90-degree triangle that's been scaled up by a factor of 2. That means that this reference angle is equal to a value of pi over 3. To find angle theta, which is going to be this angle here, I need to take pi minus pi over 3, giving me a difference of 2 pi over 3. So my final answer, -2, 2 times the square root of 3 is equal to, in polar coordinates, 4, 2 pi over 3. All right, guys, good luck.